Okay, so I'm going to do number 3 here, as we discussed, for it's arithmetically more convenient. All right, so we're going to be using n equals 4. So let's draw the picture first. The picture is, I've got this domain. Let me draw that domain. So this says x goes from 1 to 9, y goes from -2 to 2. All right. Let's see here. Yeah, let me use the... I can do that. Okay, so... That's better. Okay, so -2 to 2 on the y-axis and 1 to 9 on the x-axis. So our rectangle is about like that. Right? Now we've got n equals 4. So because n equals 4, chop everything up into 4 pieces. That works out great in both directions. Let's see here. About like that. This being as it is 1, this being 9. These numbers are 3, 5, 7. Right? Everybody happy? Okay. All right. Now that gives me then 16 16 subrectangles. And for each one of these subrectangles, now it's made a choice for us. It's made a choice. The question says use the right endpoint for the x-coordinate and use the top coordinate for the y-coordinate. So that means for whichever one I might happen to be looking at here, whichever one of these subrectangles.
Yeah, wait, how do we know if it's right?
Yeah, so the star, it's discussed in the book, but this says of the choices that you have available to you to choose, this is the one that you should choose. And xi, of course, is the one on the right. Xi is the largest coordinate in the ith subinterval. And so this just says choose the largest of those x coordinates. This says choose the largest of the y coordinates. So top right. Okay, so for that one, we're going to choose that point. So altogether then, what I need is to look at the following 16 points. Right, okay, so now what do I do with these 16 points? Well, now keep in mind we are we're interested in a double integral. It's a double integral over this domain of x times y is my integrand. Okay. This is going to be approximated by this summation. I and j go from 1 to 4. Okay, so I'm going to be multiplying xi is my x-coordinate times yj is my y-coordinate. And now I'm going to multiply that times delta a. Now I've got to think through what is delta a. Well, delta a is delta x times delta y. Delta x is 2. Right. Delta y is 1. And so that being 2, this being 1, I have that delta a is 2. All right, so this is the formula I'm going to be adding up. I'm going to be looking at summation over all these 16 terms of whatever the x-coordinate is times whatever the y-coordinate is times 2.
When we're doing that, is it all good to factor by to pull out one?
Yeah, Sure. I mean, you can factor out the 2. You just have to keep in mind that, so 2 is a common factor in all 16 terms. Now, you are going to start to notice, for example, if you start doing these first, you're going to say, you know what? Come on, the x coordinate is this common factor of 3 in all these terms. But there aren't. That's just in those 4 terms, right? That 3 is not 3; it's a 5 over here, and so the 2 is really the only common factor. So how you do this arithmetic. I mean, you can just write them all down one at a time. Do it by hand. You might make a little table, right? Where you say, all right, well, here's my my xi values, and here's my yj values, and let's see here. Right, and then each one you put 2 xi yj. So let's see now. I have to remember xi's were 3, 5, 7, and 9. The yj's were -1, 0, 1, and 2. And in each place in here you put the formula. So -6, -10. It's conveniently these are all 0. That's nice. 6, 10. Oh, that's going to. Oh, the arithmetic works out nice. How about that? I am not sure that I planned that. Let's see here. 12, 20, 28. Oh, 36. Thank you. And yeah, what does that add up to? 96? I think that adds up to 96. Yeah. Yep. Is everybody happy with this one? Okay. So yeah, I guess I should point out these other 3 parts. I mean, I just did part 3 here. Right. The other 3 parts, same kind of thing. It's just there are going to be some fractions involved. So, yeah. Okay.